Dear friends, in this lecture, we will discuss the following problem. Let f be an analytic function on C such that mod of fz is greater or equal to mod z for every z in C. Then there is a constant a with modulus greater or equal to 1 such that f of z looks like a multiplied by z. Justify your answer. Okay, solution to the problem. First, we observe that if f of alpha equal to 0, then alpha must be 0. Because mod of alpha is greater or equal to mod alpha, which implies mod alpha equal to 0, that is alpha equal to 0. That's why Taylor's expansion of fz can be written as fz equal to z to the power n multiplied by z, where n is greater or equal to 0, g of 0 is not equal to 0, and g is entire function. Again, by the given condition, modulus of fz is greater or equal to mod z implies mod of z whole to the power n minus 1 multiplied by mod of gz is greater or equal to 1, right? Since g0 is not equal to 0, so n must be less or equal to 1. So if f has a 0, then that 0 is a simple 0 and occurred at the point z equal to 0. Okay, thus the function z by fz is either an entire function or z by fz has at most removable singularity at the point z equal to 0. That means the function z by fz has a holomorphic extension. Holomorphic extension say it is h. Given that mod of fz is greater or equal to mod of z for every complex number, right? That means the function hz, the function hz is an entire and bounded function. So by Liouville's theorem, hz is constant. So by Liouville's theorem, hz is constant. Say the constant is b. Now it is given that mod of fz is greater or equal to mod z. So modulus of b is less or equal to 1, and by the construction of hz it is clear that constant b cannot be 0. Okay, thus you can write z equal to b into fz, right? So fz is some constant multiple of z, where the constant is reciprocal of b, that is modulus value is greater or equal to 1. Okay, and this completes the proof. Thank you.